with the amount of software coming through these automated CI/CD systems, I think a lot of the industry has observed that's very expensive. If we have a security incident at runtime, we know that's expensive. And so, a lot of us in this space started to ask the question, what can we do before runtime to try to prevent as much as possible?
Hi, I'm Jake Kouns, CEO of Risk-Based Security. Welcome to this edition of The Right Security, the show which we spend time talking with leaders and veterans in the security space, tackling the issues of the day.
Today, I'm joined by Dan Nurmi. Dan's co-founder and the CTO of Anchore. His primary experience includes research and applied work in things like enterprise infrastructure, containers, cloud computing, operating systems, and also high-performance scientific computing systems. He's passionate about large-scale distributed systems, from wires to white papers. He'll tell us about that. In the older days, you might even find him competing in a Capture the Flag tournament. Maybe you might even find him at DEF CON. I don't know if he wants to talk about that. And even potentially surfing and singing. Dan, welcome to the show, my friend.
Thank you very much, Jake. It's great to be here. Thanks for having me.
Perfect. Well, today, I want to spend some time talking with you about containers and supply chain security. When we first started working together in 2019, it was great to meet you and your team, and it felt good that you actually knew the importance of vulnerabilities and having complete vulnerability data. So I love that the fact that we're working with Anchore with VulnDB, so that is awesome. But I do want to start out today with a little level setting, if you don't mind. So my thought is I'm going to throw a couple words or concepts at you, and then maybe for our viewers, you can give us a little level setting, a little education on how you view these things. So I'm going to first start off and I'm going to say, what the heck is a container? And is that the same thing as an image?
Yeah, it's actually a really great question. These are important concepts that are really related to a lot of what's going on in modern development practices. So to your question, what is a container? Well, in the earlier days, I'd say 10, 15 years ago of open source development and software development, there's a lot of notions of taking an application source code and building it into something that can execute, right? That's an important step of taking source code to something that executes. And in the old days, that was basically it. We take source code, turn it into an executable, and then run it on some machine. And that's kind of the end of the day. Linux came around with distributions and vendors that really took a look at the open source ecosystem and said, there's a lot of source code out there, and a lot of people need to execute this stuff. But everybody is building it in different ways. And so they started to actually package and curate large collections of software together and, putting release numbers on them. And that's what became, Linux distributions. And that was actually really compelling for a very long time. And then around, early 2010s or so, some really smart people started to observe kind of a new kind of complexity where it's not just about the open source software, but everything else that's required to execute and share a more complex environment. No longer were we really just sort of running an application that was sort of a single executable, but new patterns like microservice-oriented systems and distributed systems and really complex things like Hadoop or complicated databases really weren't about like a single package of open source software. It's more like an entire environment, and that's configuration and binaries and all sorts of stuff that communicates. And these folks kind of came around, mostly centered around a company in an open source project called Docker, to really say, well, we can take now put it all together into an executable environment, which really changed the game from a download and install and then figure out how to execute, configure, and then run, to just a download direct to run for a much more complex set of applications. It really eased the way to be able to do that. And that's what containers are. They're an encapsulation of a bunch of software and configurations that are ready to execute in the same way in a production environment as you might be able to execute, say, as a developer. So these things they're really portable, they're storage efficient. You get cool properties like reproducible builds and unique digests that are associated with them. They're super shareable. Developers can share these really complex applications between each other very easily and compose them together to make more complex applications. So, in a nutshell, hopefully that's a good sort of overview of what containers are and why they're so important.
All right, that was really helpful, help telling us about containers. But I'm going to ask some more questions, and it hopefully won't annoy you, but you'll help us figure out here. So we know Docker is a company, but you hear people say Docker containers. So are there lots of different types of containers? Can you help us understand what is Docker and are there types of things that we should know about?
I mean, I think so Docker is a company, but was also the name of an open source project that really propelled the notion of containers, and they're super important in launching the containers idea and technologies. And so it's both interchangeably sometimes used with containers. Some people say Docker images, where they could absolutely say container images, and that would mean the same thing. But when it comes to actually the format standards, it's an interesting point. There aren't really multiple container format standards of note. One of the really compelling reasons why I think containers took off is that there's a single way, and it's important to portability. You've got a laptop that can run a container, and your production environment that might have an entire, really large scale, complex way to execute container images to actually deploy applications can run the exact same container image. And that's a really important element, I think, of why it became, so important and adopted. Perfect.
All right, I got a couple more for you still. So we hear a lot of times Kubernetes, maybe Amazon ECS. What are people saying when they're saying these things, and how does that relate to containers?
Yeah, so those are the names of container deployment or orchestration systems. So I do think it's an important distinction, and I think you referenced it in one of your first questions. When people say container images, that's pretty much like the software at rest. So you can think of it as, an RPM or a tar ball or a zip file, right? It's data and applications kind of bundled up into a file, or a collection of files that you can store in a registry or a repository. You can download these things, you can copy them around, you can put them on your hard drive, etc. Now, when it comes to actually running the application, containers are a little bit different than a normal application. That you don't just kind of run it; you run it through a container runtime system. And that instantiates, it takes the image and actually makes an instance of that application or that container image that is now running. And that can have open network ports, and it's got various types of resource constraints and things like that. So the way that these kind of container runtime systems work is you install a bunch of software on either VMs or bare metal or whatever, and that software is most commonly today, the orchestration system people use is called Kubernetes, right? So you install that platform on top of your physical or VM resources, and now you can deploy containers, and that system, Kubernetes, will orchestrate the execution of those containers. So you can say, I want to run the MySQL container over here, and I want to run Apache over there, and I want to run Hadoop. And the orchestration system, Kubernetes, will take all those incoming requests and decide where to run things optimally and get them all set up and stitch the networks together and connect them to storage and all of that infrastructure stuff. And to your second question, terms like ECS and EKS, those are the Amazon Web Services names for their various types of container orchestration systems.
So in past shows, we've talked a little bit about the CI/CD process, but we always have people asking for more education on this. So when you think about the CI/CD process, how do containers come into play with this?
That's a really interesting question. Something I'm happy to talk about because it's actually something that's new and sort of fundamental to where Anchore actually came from inception. So a CI/CD process, what that acronym stands for is continuous integration, continuous deployment, and essentially what these are pieces of software that will help you take source code and every time there's a new change, like a developer will commit a bug fix or a new feature or a security update, whatever a developer might be committing into their source code, the system will wake up, see that there's been a change, and go through a procedure. And that procedure is meant to take that change, build it, perform automatic tests. That's where the continuous integration kind of idea comes in. Every time there's a change, a whole thing kicks off and it'll make your executable application. And then the continuous delivery or continuous deployment side, the CD side of these systems, will take that executable and potentially automatically deploy it into production. And if you get all this stuff right, and organizations are putting a lot of time and effort into trying to make this whole process completely automated, then you can have a situation where developers make bug fixes, and within minutes, that bug fix is instantiated in production, running, customer facing. Right, that is possible from a functional perspective, and a CI/CD system is the tooling in between that makes that possible.
All right, I'm gonna ask another very similar question because I want to dive a little deeper into this. So I think you and I would both agree that containers are really important to evolve and have this modern DevSecOps development practice. So if you're trying to explain to someone like how they're used in this a little bit deeper, or maybe compare contrast of the old school way that we did it, which we thought was great, and how the newer school container and why they should care. Can you talk just a little more about that for us?
Totally. That's actually a really important point, which is that, how do containers play into this situation, right? CI/CD systems have been around for a very long time, and they still fundamentally kind of do the same things, right? They take source code, they make an executable thing, and then facilitate the delivery or deployment. Turns out, though, the CI part, a lot of organizations had that, right? That's the part where we're doing continuous integration, making executables. But actually doing continuous delivery and deployment was very difficult. And that kind of goes back to the definition that we talked about, or some of those fundamental reasons why containers came to be in the first place. Right? It's really hard in a sufficiently complex application environment to just take a bunch of executables that your CI is producing and deploy them automatically, because it turns out it's not just about the executables. There's so much stuff. And we're not just talking about one application. You might have a team that's got thousands of applications with thousands of updates happening every hour, producing a lot of material, and they all have to interact and be compatible. And it puts a huge burden historically on sandbox testing and functional testing, and trying to reconcile the fact that your production environment is not the same as the development environment. And this is where containers really have moved the needle, which is now that we're able to encapsulate an entire execution environment, everything the application needs all together inside of this container image, we can achieve this actual notion of CI/CD, even in the face of an organization that's got thousands and thousands of applications that all have to share the same resources, because their configurations don't have to be compatible. Container technology actually takes care of that by encapsulating the entire execution environment, allowing you to run application A and application B alongside each other, and they can have entirely different OS environments and configurations and software dependencies. They don't even have to know about each other. So that's really where containers came into the CI/CD play. Instead of just building an app executable, now modern shops are building container images and using that as the unit of deployment.
Well, that makes a lot of sense. And I think when people start to better understand that you can have lots of containers that you've pulled from places, or layered containers, or however you want to describe it, that's when you start to go, wow, that's super powerful. And then as a security person, you go, wow, that's a lot I didn't understand. Maybe I don't have visibility into. Right. So Well, we'll get into some of that, but let's talk a little bit now about shift left. We've been hearing shift left for a long time. Maybe you can tell us a little bit about what you think shift left is and why that is a big security benefit of again, shifting.
Yeah, and so first, the notion of left and right. Hopefully from some of our previous discussions so far, it sort of, you can see this whole process kind of lines up as a spectrum. It has a left-hand side, which is like source code, and the right-hand side, which is Kubernetes, or where your applications are running. Even if you're not talking about containers, there's a similar kind of spectrum. Left is source, right is running, and the CI/CD is right in the middle, right? It's the thing that's connecting the left and the right. And this notion of shift left security is something that's that's been around the industry for a while, but it's really starting to come into sharp relief and focus now, because with how much automation has been added, because you get all the benefits that we've already talked about. Like you say, the security team starts to take a look at what's going on, and you've got a lot of different software environments. You have super rapid updates. Your software surface area has just exploded, right? In terms of what versions of software and builds are actually candidates for executing in runtime. And a traditional approach, like prior to this level of automation being in place, was to essentially do runtime scanning, right? Look at your network, watch for anomalies, see what's running, even perform security scans against static artifacts on the runtime systems, right? That's something that is still important, but with the amount of software coming through these automated CI/CD systems, I think a lot of the industry has observed that's very expensive. If we have a security incident at runtime, we know that's expensive, right? To remediate, right? We have to talk to our customers. It could be a very public event, difficult and complex, expensive to handle. And so, a lot of us in this space started to ask the question, what can we do before runtime to try to prevent as much as possible? And actually building on this momentum around containers, saying we have more information now, right? The security team's worried because there's more software, but we actually have more information. Like, these container images are encapsulated environments with all of the configs and other data files and supporting dependencies all bundled together before it ever runs, right? And so, like, imagine if we have 100 things to check from our security team at runtime to make sure something's secure, but imagine we can do 80 of those things right in the CI/CD. Huge win, right? If we can prevent security things before they ever execute, it has obvious value. If we catch it in CI/CD, then that could potentially never even be customer facing, far less expensive, time consuming, and dangerous, right? And so the idea of shift left security is to really evaluate every security control and policy and practice that we have, and see how far left into this development process we can push the checks to try to catch these things as early as possible.
That makes total sense. And it's funny. Shift left, I believe, sort of came up as a buzzword when we were talking DevSecOps, but we've been using just the wording of shift left to talk to people about just basic vulnerability management. And a lot of times, people still think vuln scanning, and we'll say to them, well, if there's a vulnerability in Apache 1.0 and you're running Apache 1.0, why do you have to scan for this thing, right? You can shift it left, compact, and understand. And I think people are starting to understand that now, of compact the timeline, understand and make those risk-based decisions quicker. So I really appreciate you explaining that for us. So, okay, so we've done a lot of definition and a lot of talk, I'll say, about containers, and maybe we've beaten that a little bit too much, but let's now take it a little bit more into application. And right now, as you know, the supply chain, it's hot. Now, we would argue that it's been hot this whole time, but now it seems to get some more attention, particularly with some of the solar wind stuff, et cetera. So if I was to say to you, all right, great, I heard all this shift left stuff, I heard all of this container stuff, how do these new modern shift left security practices, how do they defend against supply chain attacks? What do you have to say if you're getting asked that question?
Yeah, and we definitely are, and this it kind of comes down to realizing at least from our perspective, these supply chain attacks really have two important stages to them, right? And I think that gets washed out sometimes in the security coverage or the sort of more public coverage of some of these incidents, where there is one stage where an attacker will compromise a supplier, right? In the SolarWinds case, that would be SolarWinds themselves. But it's not so much an attack, right? The malicious actor isn't going in and actually getting anything from SolarWinds themselves. The second stage is the actual consumer, right? And that's where the malicious actors are actually getting their value, right? They're going in and attacking the consumer by compromising the supplier. And this idea of shift left, in our opinion, really affects the suppliers more than the consumers in this particular scenario, right? The supplier is the one that's actually generating a software artifact that a consumer is, downloading and executing. And it turns out the consumer is doing everything they're supposed to do. They're getting the latest updates. They're getting security patches from their suppliers. They're doing exactly what you're supposed to do. And yet they're getting compromised. And so really the thing, in our opinion, to look at is the supplier themselves, right? And so as software suppliers, we need to be putting our own shift left security practices in place to make sure we're doing everything we can, and it's not just about moving a security check, it's about spreading it out. So we do that security check potentially multiple times in our CI/CD systems, where instead of running applications at the end of our CI/CD system, we're delivering an application to a consumer. So the same ideas of shift left when it comes to an internal application or internal production apps applies to a software supplier. It's just instead of executing, we're making software that consumers can download.
The one other thing that I think about a lot too with supply chain attacks, and we've been talking about this a long time at RBS, is that systemic risk. And so I also think, I love the concept of containers, but I also, if you think about it, a vulnerability, say one vulnerability in a container, and everyone decides I'm going to go use that container, and that container is used everywhere. One vuln now can lead to lots of problems. So I think it's eye-opening in that regard when you think about systemic risk. And just like you said, you really need to rate and evaluate and understand the vendors and the products used. And I think that's where we both agree. We do our ratings, and you're doing your deeper analysis. And I think we're going to see a lot of evolving things in this space. So, all right, I have another question for you. From time to time, people will watch, our interview series, and they'll say, "That sounds great. I love it, but wow, that seems really complicated, really overwhelming." So, what do you say to someone that feels that way? How do you recommend that a company think about getting started or implementing some of the shift left security practices, into their DevOps tool chains or whatever it may be? How do you take it from, wow, Dan seems really smart and that's too hard and I'm going to go on with the rest of my day, versus I need to take some kind of actions and get this moving?
Yeah, I mean, it's a really great question. And, I think it's clear that it's sort of incumbent on all of us software suppliers to step back and say, what can we do, right? And so, I'm a very pragmatic person when it comes to infrastructure and software development myself. So I ask these questions all the time. And the good news is, in this space, because containers in particular have these nice properties of being encapsulated environments and very portable, and there's a very few formats. New tools like the ones that we built here and continue to build here at Anchore, you can download and try out very quickly. Anchore itself has open source tools. One of them is called Sift, which is a tool that you can download, and it runs, you download it and run it in just a matter of seconds against a container image, and it'll generate a software bill of materials. A very complex, rich, valuable piece of material that you can use for forensics. For your security team might ask you for it. You might need to supply that to a consumer of your software, or we're even seeing people now starting to publish SBOMs right alongside their deliverables in public places. We have another tool called Gripe, which is also open source, free, available to download very quickly. And you can point that at a container image and you get back a vulnerability result right there in your screen. And to your question about how to use these tools, we work with a lot of community members and organizations that will take these tools and just instantly put them into your build pipelines. Anywhere you've got container images, you can put these tools in place and start generating this information right away. And then, of course, we've got other open source tools, and Anchore, our product, will then take that information, and instead of putting some of the burden on your side to consume and rationalize and use that information yourself, we have products and services where you can take that information, and then we have all sorts of policy evaluations and remediation features and things like that. The point is, there are tools that you can bring in, and without modifying the way that your infrastructure works or your CI/CD system is deployed, you can bring these security and compliance tools in, plug them in, and start extracting this information and putting enforcement in place very quickly.
Recently, there was a newly published presidential executive order on all things cyber, right? What are your thoughts on this new order? And you brought up the word SBOM. You had to do it, and we've had some few episodes in the past about SBOM and all that sort of stuff. But any particular thoughts on maybe the elevated role of SBOM in this order and containers, and what you thinking?
Yeah, this is an interesting one, right? This just came out, last week, and when I was reading through the executive order, something kind of struck me, which is, I've been involved in, companies that supply software to, other companies, other enterprise companies, or federal government, U.S. federal government or other governments. And it's pretty common for large organizations when buying software to ask the supplier for something like, hey, we're going to use your software, but in the contract it says we need you to supply all of the open source licenses that are included in dependencies of your software. And sometimes you'll even see in a contract, hey, we need you to describe or point us at your internal development security policy to do some kind of review on our side. And when I was reading the executive order, I was thinking, this is really interesting because it's in a sense a formalization of that common industry practice. And what I think is so interesting is that it's both mentioning the need for the consumer, in this case, the U.S. federal government, to get practice and policy about development practices from all suppliers, but it also calls out specifically information that's going to be required to be transmitted across the organizational boundary from supplier to consumer in the form of, say, a software bill of materials or an SBOM, right? And because there are so many customers that are software suppliers that have the U.S. federal government as a common customer, I think this might actually move the needle towards a more industry standard or an industry adopted collection of practices, software bill of materials, and other information in some standard forms that we might actually start to converge around. So I think it's actually really exciting times.
So and listening to all the what is a container, how does it apply, the government approach, the technology person. I want to ask you, do you think that containers apply or affect particular industries more than others? Is this just a tech software building thing, or are you starting to see more adoption in particular industries by a chance?
Yeah, I mean, the interesting thing about containers is I think we're only at sort of page 2 or chapter 2 maybe of containers, and at least a 10-chapter story. And definitely in the up until now, a lot of tech industry has started to agree on using containers and using those technologies to achieve this high degree of automation and efficiency in your development process. But software is everywhere, right? There are companies that 10, 15 years ago wouldn't have had their own software developers, and now it's starting to become kind of rare to find any vertical that doesn't have some in-house software developers, or at least contracted software developers writing in-house tools. And in addition, With containers, we're actually starting to see industries that might not even be developing their own software, but they still have a CI/CD system for deploying software, their own infrastructure internally. And a great way to do that, as the tech industry is sort of circled around, is by using containers. And so, to your question, we're starting to see the container as a more and more used delivery mechanism for software, not just a software development mechanism. And I think that's only going to increase.
I agree with you. We have a lot of clients that they don't want to scan. They're worried about doing security tasks that could impact productions. You think about the medical industry, manufacturing, et cetera. And so to be able to to have a container and test the heck out of it in a more safe manner and deploy things, I think we're going to see people really understand some of the value there. Well, I appreciate it. Well, hey, look, I want to talk a little bit about Anchore here. So you're founder of the company. It's not the first company you started, so that makes you a very special kind of person to want to go on another ride like that again. But give me a little bit about Anchore, right? You guys have some open source roots. You mentioned some of these free offerings. Tell me a little bit about how it started and a little bit on the journey.
Sure. Yeah, I'm happy to. And so around about 2015 or so, myself and Saeed Ziwani is the other co-founder of Anchore. We worked together in the past. We both came from open source, large scale infrastructure, data centers, you can see from space kind of careers and interests. And, when we got together in 2015 and kind of looking at what was going on in the industry, no question, containers were really on the upswing when it came to momentum. And in open source, in my experience, any technology that's experiencing good technology that's experiencing this kind of momentum is something to start thinking about really carefully, because as soon as a community starts to build up and developers start to get interested, ultimately there's going to be ramifications and impact on the global, software infrastructure story. And when we took a look at where container technology was at the time, we kind of assumed and predicted that, big companies are going to be able to handle the storage and network and orchestration kind of ideas. Docker had that in hand, and Google, we knew it was doing a lot of stuff with containers that eventually, came out with Kubernetes as available to all. But it was more in our minds about what if we imagine containers are just everywhere. Everybody has achieved container bliss, and they're getting all the value out of containers that you're supposed to get functionally. What are the real challenges at that point? What looks different other than just the infrastructure? And it was this stuff that we've been talking about, this rapid, everything automated, no human beings between developers having ideas and those ideas manifesting in production. That vision of what the world is going to look like looked very different than where we were in 2014, 2015 without containers. And one of the big impediments that we predicted to getting there for enterprises and regulated industries and governments and things like that is absolutely going to be in the security and compliance space. There's so much software being generated in their own unique combinations and ways. That's where we thought there was going to be significant challenge, and new technology and tools and mechanisms were needed to try to meet that challenge. And that's where we started with the idea for Anchore technology. And back then we started thinking we need to build a really serious data analysis system, because what we're talking about here is a huge amount of data, lots of churn, lots of variance coming in, and there's very clear things you need to be able to do. You need security checks and compliance checks and best practices enforcement, because there's a lot of variability in the data. And so what does that look like? That's where we started, and that's what we're still building today. We're building a system that can take all of that information and all that churn and allow you to specify your security policies and compliance policies and best practices policies in a very simple way, and then apply all of those policies to the dramatically larger set of constantly churning software that's being put through your CI/CD systems. So in a nutshell, that's really where Anchore came from, and what it is we're still doing today, and helping our customers and users resolve.
I think it's great that you guys have some free offerings and some of your commercial offerings, and I think that's where we've come in with Anchore Enterprise. I remember when we first started working together and looking at the vulnerability stuff. A lot of times we'll say, "Hey, look, we're collecting more vulns than anyone else," and people don't always want to believe it. But I know I think it was September of 2019, you guys actually took Anchore Enterprise and looked at 6 images. And the testing and the difference between what Anchore Enterprise with VulnDB would find without it's stunning, right? And the world since 2019 has only continued to morph and change, but get worse with a huge amount of data, and for people to try to figure out what do they need to fix and when and prioritize. So I've seen you guys do some really amazing things, and I love it. Now, I know that you just released a brand new version, I think, right? Version 3.0, just maybe a month or so ago in March. And if I remember, I think one of the biggest things that I liked about it had a lot to it, don't get me wrong, but some of the remediation tracking, I think you call it actions or something, but it allows you to kind of say, great, there's a bunch of vulns, and then be able to kind of figure out what to do. What any thoughts on that new version, or maybe sort of what you guys have coming up next that you're excited about?
Yeah. Thanks for bringing that up. We're really excited about version 3.0. And like I was saying, kind of the core of what Anchore Enterprise and our open source tools do is they take data on one side and provide, run applications and do various security and compliance and best practices enforcement on the other. And we have a good platform for that. We've been doing that for a number of years. 3.0, we really started to look more on that next step. Right now, we've been working with very large enterprise customers, and the U.S. federal government uses Anchore as well for a number of different container security efforts. Now that we've been working with customers and actually observing, yes, the data is important, and those scans are important, and surfacing vulnerabilities and leaked credentials and malware, and the reports being generated are very important. But we started to observe there's some common patterns about what the next thing that a security team or a DevOps team or a developer will want to do with that information. And again, we leverage the fact that with containers, there's some uniformity into how containers are built and how they are assembled. And we can take some of those security findings and actually say, not only can we just report on it, we can tell you, hey, there's something. We can recommend a next step here to get you to getting it fixed and help you to track where in your pipeline, that next step should happen. And that's a part of 3.0 and our enterprise product now. And we're actually going a lot further with that concept in our future products as well. We're actually starting to take a really close look at every element of your CI/CD system, including a little bit of runtime and a little bit of source code. And we're starting to spread out what our platform can actually inspect in terms of gathering data, providing an even richer remediation scenario and assessment tool that not only can be used for surfacing information, but we're starting to break into things like forensics and doing a deep impact assessment, those kind of additionally important security operations.
Sounds exciting. I know you guys also published a new white paper. We'll throw a link in the show notes like we usually do. I think it's called Prevent Software Supply Chain Attacks for Cloud Native Apps. So I think that's pretty good. Hope maybe people learn some more stuff there. But I got one last question for you, and it's kind of pulling it all together, and maybe some things we've already covered, but maybe if you can try to concisely, give some people advice for anyone out there that's already struggling with too much work, too many vulnerabilities, and now we're saying that there's containers we have to worry about and all this other stuff. We're going to argue even how to pronounce it properly. What advice do you give someone in a security role or at their organization to get started with that risk-based vuln management program to make sure you're not missing out on some of this new technology?
Yeah, I mean that's an important idea. I think the magnitude of the problem. If you're a security person today or a security engineer, and you're starting to see containers and your developers doing stuff, it looks really kind of nerve-wracking, right? Because there's so much data. But the realization, I think, and we've talked about it here a number of times, is that yes, there's a lot of software variance, but the way it's being packaged is something that tools like Anchore and other tools out there in the world can handle, right? And so there are good solutions. They're not that hard to get put in place. And you immediately start to be able to get information in the way that you're probably more familiar with in a way that's a lot easier than you might think, right? So there are existing technologies. That's what we spend all day on here over here at Anchore, trying to build for you, to just say, bring this thing in, hook it up to your CI/CD, and you start getting vulnerability reports. You don't have to worry about the variance, right? Our tools try to handle that for you. So I think that the biggest thing I recommend is, yes, this is a problem, but there is technology that can help address it. That's pretty easy to get going.
Dan, thank you so much for your time today. This was extremely insightful.
Thank you very much, Jake. It was great to be here and great to talk to you.
All right. Well, thank you for tuning into this episode of The Right Security. As always, we'll have more details and links in the show notes. Don't forget to subscribe wherever you get your podcasts, leave a review, all that sort of stuff. And you can learn more about RBS at our website as well as Anchor. Thank you for tuning in.
The right security, not security. The right security, not just security.